This spacesuit, built in 1974, was reported to cost between $15 and $22 million. Today, that would be about $150 million. Having not delivered any new mission-ready extravehicular suits since then, NASA is running out of spacesuits. In fact, NASA are down to just 4 flight-ready EVA suits. Since 2009, NASA has invested more than $200 million in spacesuit development, recently unveiling the XEMU prototype. But NASA still does not have a new fleet of spacesuits. So why has it taken so long for new spacesuits to be built? And what makes them so expensive?
Spacesuits are so expensive because they're complex, human-shaped spacecraft. Think about them in terms of spacecraft, not as work clothes. A spacesuit has to protect an astronaut from the vacuum of space, from radiation coming from the sun and other bodies, and it has to protect against fast-traveling particles that are traveling up to 18,000 miles an hour that could penetrate the suit. They provide oxygen, communications, telemetry, and everything else that a human needs to survive, all rolled into one tiny human-formed spacecraft.
But the spacesuits NASA currently uses are more than 40 years old. 18 suits were developed for the Space Shuttle program in 1974 and have vastly overworked their original 15-year life design. Suit number 1 was only used for certification, while Suit 2 was destroyed during ground testing. 2 suits were lost in the Challenger disaster in 1986, and another 2 in the Columbia disaster in 2003. The most recent spacesuit loss was Unit 17 during SpaceX 7's cargo mission mishap. The exact cost to replace this unit is unknown, but estimates range as high as $250 million. For the remaining 11 suits, the damage is mounting, with 7 in various stages of refurbishment and maintenance. That leaves only 4 flight-ready spacesuits aboard the International Space Station. In fact, NASA's first all-female spacewalk was postponed because the space station had only 1 medium-sized suit. This milestone was finally achieved when NASA sent up a medium torso shell to fit the existing larger suit. NASA has invested about $250 million developing the XEMU suit for its Artemis program, which plans to take humans back to the surface of the Moon by 2024, with a view to eventually go to Mars. With that goal fast approaching and the number of existing spacesuits dwindling, NASA engineers face a new kind of space race.
There is absolutely a sense of urgency, not only because of the number of suits itself is relatively small, but the individual components that we use to keep the suits healthy and moving forward is also dwindling. A great example of that is the carbon dioxide sensors. The design that the current suits fly is a heritage design, some of the components of which are no longer produced. Some of the vendors that made those components no longer even exist. And so today, the CO2 sensor is a great example of a component where a replacement design that will work for both the existing suit and the new suit, basically be a drop-in replacement that's compatible with both suit designs.
These people-shaped spacecraft are packed with complex components, but the most expensive parts are subject to debate.
The most expensive component of the spacesuit are the gloves. The gloves are the most complex because the astronauts need them for manual dexterity to do meaningful work in space. You see the interior, you see a system of pulleys and strings that hold it together. And then on the outside of the glove, you see the system of heat radiators that allow the astronaut to keep their hands warm.
The gloves are an amazing and intricate component, but at the end of the day, the pressure garment, including the gloves, is actually less expensive than the life support system. The backpack that is worn on the back of the suit is a highly compressed set of technologies that do everything from maintain temperature to remove carbon dioxide and continue to provide pressure inside the suit itself. And I think in the end, several of those components are each more expensive than most of the other garment components like the gloves.
But even these expertly engineered suits can go wrong. In 2013, European Space Agency astronaut Luca Parmitano reported that his helmet started filling with water.
That stuff on your forehead is not sweat?
No, it's not.
Oh, I see. Hatch coming open.
Copy all, Chris. You could have some towels ready, that would be great.
In total, almost 1.5 litres of water leaked into his helmet, threatening to drown Parmitano mid-spacewalk. But considering that NASA's Apollo-era spacesuits allowed 12 humans to walk on the moon 50 years ago, and considering the Space Shuttle-era suits have been used on over 200 spacewalks, is such a large investment in new spacesuits needed?
Well, that depends on what you're going to ask the astronauts to do. Walking on Mars is different from walking on the moon. It's a different environment, it has different hazards. So when you're picking these assignments for astronauts, you have to take into account, do you want the astronaut to be able to walk, bend over, pick up things, or will he or she be carrying something? So you have all those considerations that have to fold into that design.
We believe it is a necessity. Some of the components and some of the design concepts are no longer consistent with our values and expectations in terms of the quantity and distribution of crew members that we fit. I believe that, yes, the investment is appropriate and worthwhile. All those dollars get spent here on the ground, and they're returned to us in ways that ultimately yield benefits for all of humanity and for the taxpayers here in this country.
In an effort to develop technology at lower costs, NASA often sets design challenges for innovation, sometimes partnering with the designers and companies who impress the most. In the 2009 Astronaut Glove Challenge, Ted Southern bagged the second-place prize of $100,000. He and his partner, Nikolai Moiseev, a leading Russian spacesuit engineer, used their winnings to form Final Frontier Design.
We as a business were formed about 10 years ago and have worked with NASA on components of EVA suits for that whole time. NASA's our biggest customer, and we've delivered prototype components for the suit, including the glove, elbow, shoulder assemblies, parts and pieces. But just over the last 2 years, we've focused on bringing the whole system together.
And Final Frontier plans to build its own EVA suit much, much cheaper than NASA's.
We intend to deliver flight-level suits with similar requirements as NASA's. Our suits are made with the same material as the suits that NASA used down to the mill. Traditionally, spacesuits are very expensive. I expect our suit development will be in the multi-million-dollar range, but I hope that our suit EVA system will be around $2 million a piece or less.
How does NASA's spacesuit costs compare with other countries? Russia's equivalent of the EMU suit is called the Orlan. Like NASA, it also has 4 suits aboard the space station, but it also has reserves, both at the Cosmonaut Training Center in Star City, Russia, and at Johnson Space Center in Houston, Texas. According to Nikolai Moiseev, who is one of the few engineers to work on both America's EMU and Russia's Orlan, unlike NASA, Roscosmos has continually developed new generations of spacesuits. Moiseev personally participated in the development of 5 generations of Russian spacesuits, and estimates that 24 units were made between 1997 and 2002, with a further 24 units made between 2002 and 2019. Roscosmos is also developing a new EVA suit for Russia's first proposed moon landing by 2030. With Russian technology in a cycle of constant development and American EMU fleets continuing to age, more commercial opportunities could become available for private companies like Final Frontier to develop spacesuit technologies at lower prices. In 2017, Elon Musk revealed the SpaceX IVA spacesuit. Although this intravehicular suit is only for use inside the spacecraft, its 3D printed helmet and custom-made garments are a glimpse into the future of commercial spacewear. But is there an actual need for cheaper spacesuits? Or is space exploration unavoidably expensive?
I believe the world needs cheaper spacesuits because, in my opinion, it's inevitable that we will expand past the surface of the Earth. We need to take advantage of the resources of space to keep our planet healthy and alive. So whether it's spacesuits or rocket technology or means of living in microgravity, all of these things I think are important for the future of humanity.